So now in this video we're going to look at an interesting property of the N Channel JFET right here. So JFETs in general, they can be made into a current source. If you tie their gate and their source together and then you put the source directly to the negative supply, you get the IDSS. You get the current that's going to flow through the component. And it's going to kind of set the component. I think it changes a little bit with voltage, but for the most part, first you have the part number. So the part number is going to give you a range of current. The J310, which I have from the Joe Knows Electronics Semiconductor Kit. I may have 5, maybe 6 of them. This would be number 5 right there. That's not written very well, but it says Joe Knows Electronics on there. So I got a bunch of different semiconductors, and this is the one that I got. But when I compare it to other JFETs, this one looks like it's going to provide more current than the majority of them when you look at their IDSS. So it might be down to 24 milliamps of current, or it may be up to 60 milliamps of current for any given J310. You actually have to test it yourself and see what you got. Now, the maximum power, you know, how hot you can get it, 350 milliwatts right there. I did the math that if it's going to let 30 milliamps of current through it, and we put 5 volts across it, that'll be 0.15 watts, which is close to half of this. And so is if we get, you know, to 0.03 amps, I'm going to stop raising the voltage at about 5 volts right there. So now we got the power supply and limited current to 60 milliamps, but we would have to keep the voltage really low if it was a 60 milliamp one. And this is actually not as high as we're going to see that it actually gets. I think it's going to be somewhere between 30 and 36. I believe it's going to be 36. I'm not sure exactly what voltage you got to measure it. But there you can see 2 volts. We got to 32 milliamps, and it's holding pretty steady. This isn't as accurate as a multimeter, but in case, you're going to see I bump it up, and it's holding, you know, relatively steady. I'm going to kind of jump this up quick. We went up a whole another volt, and it's still right around 36, and then 5 volts, around 36. And as we saw before, this is going to get quite warm, probably not enough to damage it really quickly, but I'm going to taper it down, and we'll stop at like 3 volts right there. So now that is our maximum current. We can actually set a current by putting a resistor between the source and ground. So that is the middle pin. And before we do that, I'm going to bring the power supply over here. And I guess we could leave it at 3 volts right now. But I'm going to turn the power off because we're going to rewire things. You should always turn the power off when you rewire things. So I got to pluck the middle one. I find these pliers here do a good job of grabbing these, even if they're in a pile of jumpers. And so this is a 510 ohm resistor. So the another video I did, I want I believe 2500 to get the current I want. So at this 510, I believe we'll get a fair amount more current. So looks like probably about 3 milliamps of current, and I don't think there's a formula. I think you just try different value resistors until you get the current you want. But again, we should be able to go up to 4 or 5. It should hold about steady. So maybe we were slightly, and I could go higher because we got current limited right now. You know, we got 6 volts times 0.004 amps. You know, much less. That would be a 24 right there milliwatts. Far less than the 0.35 watt maximum. I could go up to 10 volts right there. We got about 5 milliamps current. So yeah, it's holding pretty steady right there. You know, it's changing a little bit as we change the voltage. So it looks like between 3 and 7, probably not changing a ton. We could actually measure the current with a multimeter. So now, to measure current, of course, we have to create a gap in the circuit. I'm going to set this to measure milliamps of current right there, and we'll see what we got at 6 volts. Once I turn the power is on right there. So I thought I'd turn the power off to rewire it, but I probably did not. But in any case, let's measure that current, and we got to complete it through there. So yeah, this is showing 4.37 milliamps of current. This is more accurate than what is shown on the power supply. The meter is just more accurate. Be aware of that. So let's go up to a 10. Let's even go up to 12. Why not? There you go. Should be about the same current. We just doubled the voltage though. And yeah, there we go. Pretty much spot on the same amount of current. That should be even if we add a load. So I got a blue LED because they're brighter than red LEDs at 4 milliamps of current and about 4.5. I can't remember exactly what it was. But there we go. Pretty much spot on. We just went from no load at all to a blue LED, which drops about 3 volts. And so, you know, that's a significant load going from nothing to an LED, even though the LED in the grand scheme of things is not a large load. But yeah, we got a current source right there. That's simple. Just need to pick the right value resistor and stay underneath the IDSS, whatever the maximum current is going to be, which is probably around 36 milliamps of current, approximately, for this component. So as long as we stay like 10, 5, whatever, in that range, this should be pretty reliable. Now, normally, I power circuits at 5 volts, so I'm going to go to that. And usually, I keep it below 20 milliamps of current. So I'm going to set the power supply back down to that. Just so when I wire something up, I don't have a higher voltage and more current than would be safe for that load, possibly. And we'll set this off, because generally, I don't always look at the power supply when I wire up circuits. I assume it's at this setting, which I should not do. I should always check it. But I probably don't most of the time, but I often don't. But in any case, hope you enjoyed. Make sure you check out one of the other videos I post on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.